Hello guys, my name is Bob. Welcome to the Excel Math channel. And today we're going to solve, five probabilities with z-scores using the normal curve table. All right, so we shall not, you know, wait further. Let's go to the two questions down here. So the first question asks you to find the probability that the z value is smaller or equals to 1.27. So what does it mean? It means that if we were to look at this normal curve, um, you are trying to find the probability to the left side of the z value, which is equivalent to 1.27. In this right hand side itself of the screen, you can see this table. This is called the normal table, in which the center value represents the probability or the probability to the left side of the z values. Um, so if we were to find out the probability that z is less or equals to 1.27, how do we use the table? First thing we got to do is we got to look at the first two numbers of the z values. So the first two numbers of the z values corresponds to the first column of the normal table. As you can see, it was 1.2, and then the last digit corresponds to the first row, okay, which is 0.07. And then you kind of like match, try and match this number with this number itself. Is actually 0.8980. So the probability that z is small equals to 1.27 is equals to 0.8980. So that's how you use the normal curve table. Right, so the next one comes a bit complicated because you are dealing with z values that is smaller or equals to of z values is equivalent to a negative value. So you want to find the probability that z is smaller or equals to negative 0.50, and for this normal curve table, the thing is that you are not able to see a negative z value. So what do you do here? You kind of like, you need to play around with the probability down here by understanding these normal curves. Right, so we are trying to find the probability that is to the left side of the z, which is small or equals to negative 0.50. So this is equivalent to taking, this whole thing. Uh, the white line represents the white vertical line represents the z values of 0. So you are actually taking, this whole thing minus away this thing down here. So to phrase it, this probability that z is smaller or equals to negative 0.50 is equivalent to the probability of z that is smaller or equals to 0, subtracting away the probability that z is between negative 0.5 and 0. All right, so this is the probability that's between negative 0.5 and 0 of the z values. All right, so this actually is equivalent to the probability that z is between 0 and 0.5. Why is it so? It's because the normal curve itself is symmetrical, so the area here is the same as the area here. So this is 0.5, so the area here is equivalent to the area here because the normal curve is symmetrical around 0. All right, and from here itself we have to do another round of manipulation. So what do we mean? Okay, we basically, this probability that z is between 0 and 0.5 is the same as the probability that z is less or equals to 0.5, subtracting away the probability that z is less or equals to 0. All right, so we know that the probability that z is less or equals to 0 is 0.5 according to this normal curve table. This is 0.5, so this is 0.5. All right, let me just denote it by blue. So this is 0.50. All right. Okay, so the probability that z is less or equals to 0.5. So if you're to use the normal curve itself, the first two digit itself is here. Okay, because the first column is the first two digit of the z values, so it's 0.5, and then the last digit is 0, so it's just here. And then we match this. So here we know that the answer itself is actually 0.8980. 0.6915. Subtracting away probability that z is less than 0 is 0.5. So this is equivalent to 0.50 minus away. We have to work this out, so the answer to this is actually 0.1915, and then the final answer is actually 0.5 minus away 0.1915. Working out in the calculator, the answer is 0.3085, and that is the final answer to this second question. It's a little bit long, but the first thing that you have to do is to convert everything into some format, okay, of the probability that is of z that is lesser or equals to a specific value, as you can see down here. All right, before you can actually use the normal curve table to plug in to substitute the probability to this notation itself. All right, that's it for this video. Thank you guys for watching, and I hope you understand about how to use the normal curve table to solve the problems. I will see you in the next video. Thank you guys.